Hello everyone, and welcome to your introduction to 1.7 and 1.8, which deals with deductive structure and statements of logic. Now, just as a forewarning, this will likely not be all crystal clear by the time this is over. The purpose of this is to kind of introduce it and kind of plant the seed, so that way when we see it again in class, it'll make a little bit more sense, and we'll be able to let it absorb and actually do a little bit of work with it. So let's take a look. We've got deductive structure elements. There's 4 of them. 1, we've got undefined terms, which are our givens, etc. We've got postulates, which are unproved assumptions. We've got definitions, which state the meaning of a term. And we have theorems, which are statements that can be proved. And we currently have 2 theorems that we're using. The one about if you have 2 right angles, then they are congruent, as well as the if you have 2 straight angles, they are congruent. Those are both theorems that we have proven and used. So for logic purposes, we want to know if we can reverse these. And one quality of definitions that makes them unique is that they're all reversible. For example, a right angle is an angle whose measure is exactly 90 degrees. And the reverse of that is also true. An angle that measures exactly 90 degrees is called a right angle. Theorems and postulates, some of them can be reversed, some of them can't be. So just don't assume they can. Definitions are the only ones that for sure we can reverse them. And then the converse of any statement is the reverse of the statement. So just kind of flip-flopping, just like we saw with the definition. We just flip-flopped the first and the second part, which we'll look at a little bit more later. So write the converse of if it is raining, then it is warm. Well, flip-flop your first part and your second part, essentially. If it is warm, then it is raining. So get another one. Write the converse of if a point divides a segment into 2 congruent segments, then it is the midpoint of the segment. So we've got 2 phrases, essentially. So we've got the point dividing a segment into 2 congruent segments, as well as it is the midpoint of the segment. So the converse of this, we're going to essentially, again, flip-flop those 2 parts. So if a point is the midpoint of a segment, then it divides the segment into 2 congruent segments. Declarative versus conditional. Consider theorem 1 dealing with the right angles being congruent. The declarative form, just the statement, 2 right angles are congruent. You're stating it just like a fact. The conditional form, if 2 angles are right angles, then they are congruent. So this is that if-then format that we see we should be having in our proofs. So with these if-then statements, they're called conditional statements, as we just saw. The if part is called our hypothesis, and the then part is called the conclusion. We use the pattern of if P, then Q, and sometimes instead of writing out all those words, we can use the symbols P, and then we see an arrow Q, which we read as P implies Q. So these two can kind of be used interchangeably. Sometimes we'll use if P then Q, sometimes we'll use P implies Q. Typically this is obviously going to be a little bit shorter, and we'll kind of get used to writing in that kind of format. So a negation. Negation of a statement is the opposite of a statement, and we signify that as the little tilde and then whatever statement it is. In this case, we're just calling it statement P. So an example, it is sunny becomes it is not sunny. It is not cloudy becomes it is cloudy. So we're taking the opposite of whatever a statement is saying before. If there wasn't a not in there, we're inserting a not. If there was a not in there, we're taking it out. So what is the negation of it is not easy to negate statements? Well, I see that there's a not there, so we're going to get rid of it and say it is easy to negate statements, which hopefully you see that it is. Converse, inverse, and contrapositive. So the converse, we've seen, switch the hypothesis and the conclusion. The That's our little flip-flop. The inverse, we negate the hypothesis and the conclusion. So if we had if P then Q, it becomes if not P, then not Q. Contrapositive, switch and negate the hypothesis and conclusion. So if we had if P then Q, it becomes if not Q, then not P. So let's take a look at examples so this kind of makes some sort of, you know, sense other than P's and Q's. So find the contrapositive, inverse, and converse of if you live in Chicago, then you live in Illinois. Converse, we flip-flop our two parts. So it becomes if you live in Illinois, you live in Chicago, which is not true, even though most people probably say they're from Chicago anyway. The inverse, we negate two parts. If you don't live in Chicago, then you don't live in Illinois. Again, not a true statement, although Chicagoans may feel otherwise. And then the contrapositive, we flip and negate. So if you don't live in Illinois, then you don't live in Chicago, which is a true statement. So sometimes when we have a statement, sometimes when we do the converse, inverse, and contrapositive, sometimes they'll be true and sometimes not. So don't assume one way or another. Important tidbits. Theorem 3. If a conditional statement is true, then the contrapositive is also true. So this kind of follows a chain of reasoning, which we're definitely going to work with in class. But we have, so if P implies Q and Q implies R, then P implies R. So let's take a quick look at something that isn't just a bunch of letters. Let's say we have an example of if you have an Xbox, then you have a TV. And if you have a TV, then you watch TV. We can draw the conclusion that if you have an Xbox, then you watch TV. So this, if you have an Xbox part, is kind of like our P, then you have a TV, Q. If you have a TV, same statement, Q, then you watch TV, R. So the Q's kind of, you know, go by the wayside, and then we're just left with the beginning part and the end part. Caution. They won't always be written in a nice order for you. Sometimes we'll have to move statements around, sometimes we'll have to find contrapositives, and it can become a lot of fun, but also it can become a little bit of a headache. So being able to just kind of write whatever statements we have in the symbolic form saves you the trouble of rewriting things every time to see which way it flows. It's just kind of a shortcut that's helpful. So that's it for now. We'll definitely be doing a lot more work with this in class so that way you feel at least a little bit more comfortable with it than you do now. So kind of stick this in the back of your mind. We'll get to it in class and have a good day.